Hi everyone. This is the second video in chapter 3, expressions and polynomials. In this video, we are going to look at 6 learning objectives. Basically, we want to learn some basic definitions, terminologies about monomials and polynomials. Also, identify the degree of a given polynomial, and also how to write a polynomial in the descending order. So let's look at these objectives one by one. First, what is a monomial? Apparently, monomial means one, right? So you only have one term, basically. And this is a definition. It is an expression that is either a constant or a product of a constant. Constant means a number, or a product of a number and variables. And that variables are raised to a whole number of powers. It means if that variable has an exponent, it has to be a whole number. And we know a whole number starts with 0, right? 0, 1, 2, 3, 4, and so on. They are called whole numbers. So let's look at this example 1 to determine whether the given expressions are monomials or not. One by one. 5x, if it is a monomial, I'm going to use a check mark. If it is not, I'm going to use an x to indicate it is not a monomial. The first one, the answer is yes, because it's a product of a number or constant and a variable raised to a whole number power. Without any exponent, it means exactly positive 1. 1x is x, so we don't have to write that 1. Now, second one, negative 4xy cubed. Yeah, this one answer is also a yes. It's a product of a constant number and a variable or variables raised to a whole number power. We have 2 variables, and this is 1, this is 3. It's a whole number power, and they multiply together. It has to be a product of a number and variables. We cannot have plus minus in the monomial. So third one, x to the 6th power. And this answer also is a yes, because this is the product of 1 and a variable raised to a whole number power. When you multiply by 1, it won't change anything, so we don't write that 1. So there's a hidden 1 here. So this answer is also a monomial. Now 8, this one, answer is also a yes. First of all, it comes from definition, which says either it is a constant or a product of constant and variables. So this is a constant. So by definition, it is a monomial. But also, this actually is can be written as product of a constant number and a variable raised to a power of whole number. So which is this? If we use x to represent the variable, is 0. Any number other than 0, when raised to a power of 0, will be equal to 1. So this is equal to 1 actually. 1 times 8 is still 8. That's why we don't write it if we have 0 power, because it is equivalent to 1. Now I'm going to take this opportunity just to show you 2 or 3 examples. Any number raised to the power of 0 is 1. Later on down the road, when we talk about negative powers and operations with exponential expressions, we may have opportunity to address this in detail. But for now, let's just look at some examples. Say 1.2 to the power of 0 equals 1. Now let's get a negative number, negative ugly number, 0.123. Negative 0.123 raised to the power of 0 equal to 1. So you see that anything to the power of 0 equals. That's why this one also considered monomial. Now, next one, 5 over xy, the answer is no. because apparently 5 over xy, that's not product anymore. It's a quotient. So this one, the answer is no. And the next one, 3x squared plus 5x minus 4. Actually, we have 3 terms. It's not a monomial anymore. Mono means 1. And again, it has to be a product of a constant and variables. This is not a product. This is called addition and subtraction. Okay, now let's go to the next page. And this is the first set of exercise questions. All of the answers to exercise questions are in the comment area below the video. And if you have questions, also post your questions in the comment area. Now, let's move on to the next objective. We want to identify the coefficient and the degree of a monomial. So what is a coefficient? Remember when we define the monomial, which is the product of a constant number and the variable raised to the whole number power. So this coefficient is that constant part. It's a numerical part in that monomial. What is the degree of a monomial? The sum of all of the exponents of all the variables in that monomial. So it's not the exponent of single variable. If you have multi variables in that monomial, you're going to add all of the exponents on those variables, and the sum is called the degree of that monomial. Okay, couple of examples here. We want to identify the coefficient and the degree of each monomial. So we do this one by one. Numerical part, product of constant and variable part, right? This constant part is called a coefficient. So let's do it this way. It isn't like a table, so I don't have to rewrite these two words over and over again. Coefficient, and this is degree. So first one coefficient is -7. Degree, apparently we only have one variable. We just read this exponent, whatever it is. Degree is 2. So this is called degree 2 monomial. Next one. So without a number in front of variable, you can always view it as 1. So this is -1. Coefficient is -1. It's like -1 times cube. And now we have 2 variables. The degree of this monomial is the sum of all of the exponents. So this is 1, this is 3, so degree is 4. And next one, we have 17. Apparently coefficient is 17 because it's constant number. How about the degree? I remember I wrote the previous one, say 8 times x to the power of 0, right? If you have constant number, it's like you have a hidden variable part just raised to the power of 0. So imagine this one, 17 times x to the 0. So your degree is 0. So this one. Degree represents how many of that variables in total, how many of those variables. You have 0 variables, just to make sense. Okay, this is the second set of exercise. Our next learning objective, we want to identify polynomials and their terms. So we just learned monomial, which is just a constant number or the product of a constant number and variables raised to the whole number powers, right? Now, what is a polynomial? A polynomial is either a monomial, it's right, it's not wrong. Monomial is just a special case of polynomial. Poly usually means multiple, right? And if you only have one, it's a monomial. This is just considered to be a special case of polynomial, or a sum of monomials. So you have the expression, you have multi-terms. Each term is a monomial, then we can call that expression polynomial. It just composed of multiples of monomials. So in other words, either one monomial or monomials. That's called a polynomial. Some examples. Well, we have 4 of this actually. So monomial, in general, we call it polynomial. This is a monomial. Each one of these components is a monomial. So they are all polynomial examples. Each unit is a monomial. So either they have plus or minus in front of them. Now, this is the examples of polynomials. Now, whenever we work with polynomial, we have to know what is called a simplest form, because we always want to simplify an expression to its simplest form. So what is the simplest form of an expression? That is an expression written with the fewest symbols possible. That means you cannot reduce them further. That will be called simplest form. And later on, we're going to have this. So now, this particular polynomial, 9x cubed minus 4x squared plus 8x minus 6, has only one variable x in it. And this kind of polynomial is called polynomial in one variable. Whatever it is, you could replace all of the x's with y's. It still be called a one variable polynomial. Now, as comparison, the next one, 2x squared plus 5xy plus 8y is also a polynomial because each unit is a monomial, but they have 2 variables in it. So whenever you have more than one variable in the polynomial, we can call it a multivariable polynomial. No matter it's 2, 3, 4, or many. So they are called multivariable polynomials. Now let's look at our next example. In these examples, we have 2 of those. We want to identify the terms in the polynomial and their coefficients. So what is a term? Look at this, each unit is monomial. A term is just one of these units. This units including the sign in front of it, because all of this can be written in terms of addition. For example, 9x cubed plus negative 4x squared is equivalent to 9x cubed minus 4x squared. Just like 4 minus 3 is equivalent to 4 plus negative 3. Any unit separated by plus is called a term. So instead of saying the 3 is term, we say negative 3 because it's written as plus negative 3. Any unit separated by plus is a term. That's why when we identify terms, we want to include the sign in front of each of those terms. Okay, we want to identify the term and also their coefficients. So first term, 9x cubed, and coefficient, let's just use a code to represent coefficient, that is 9. And the second term is negative 4x squared, and coefficient is negative 4. Make sure you include the negative sign. And our third term is 8x, positive 8x. You don't have to write positive sign if it is positive. And the coefficient is 8. And the last one, a fourth term, and it is negative 6. Coefficient is negative 6. Yeah, it's a constant term. And B, we have a B. So let's redo it on the right side. And the first term, and second term, third one, and the fourth one. How many? We have 4. And first term is 4y to the fourth power. Coefficient is 4. And this coefficient. And the second term is negative 8y cubed. And the coefficient is negative 8. And the third one is negative y. Coefficient is negative 1. That's hidden 1 here. And the last one is positive 2. Coefficient also positive 2. So this is how we identify the coefficients and identify the terms in a given polynomial. And you have two similar questions here for exercise number 3. Now, some of these polynomials, remember, even if you have monomial, we can officially call it polynomial. It's a special polynomial. But some of these polynomials have their own special dedicated names because they're popular. They're popular. So the first one is that for monomial is a single term polynomial. That's why we call it a monomial, single term. For a two-term monomial, we call it binomial, and also very popular. It has its own name. It's called binomial. We also have a special name for three-term polynomial. We call it trinomial. So monomial, binomial, trinomial. So for anything more than 3 terms, we don't have special names anymore. It's just a regular polynomials. Okay, example 4 indicate whether the polynomial is a monomial, binomial, trinomial, or has no special name. So when we have more than 3 terms, they don't have special names. Apparently, monomial, only one term. And binomial, we have 2 monomials. This is called a binomial. And trinomial. And we have 4 terms, no special name. This one has no special name. So it's super easy. And this is our fourth set of exercise questions. There's one more here. Learning objective. We have, I remember we have 6 at the beginning, right? I didn't count, but we have plenty today. Identify the degree of a polynomial. We already learned the degree of a monomial, which is the sum of all of the whole number exponents. We only have whole number exponents of a monomial. So what is the degree of a polynomial? Basically, this is the highest degree of all of those monomials. Whichever has the highest degree among all of those monomials is going to be called the degree of whole polynomial. So let's look at examples. Identify the degree of each polynomial. So this is the first one. We look at all of these monomials, we pick the highest degree. So this one is 3, this one is 6, this one is 2, this one is 1, this one is 0. So this is the degree of 6 polynomial. 6 is highest exponent. And we only have one variable polynomial. We don't need to add any exponent. So this is my highest. So this is degree 6 polynomial. Now the next one. This one is 7, is 5, is 9. This one is 0, 9 is highest. So this is degree 9 polynomial. And when we say degree, it's not the number in front of these terms, which are called coefficients. It's about the sum of exponents on each polynomial. Okay. Now your exercise questions as usual. Enough exercise is essential, is necessary in learning mathematics. Our next objective is to write polynomials in descending order of degree. So highest degree term going to be the very first term. in your writing, and then the next highest going to be the second term. So now let's look at some of the examples on the next page. So we have this example 6. Write each polynomial in descending order of degree. So identify the highest, which is 5, which is negative term. So negative 3x to the 5th. And the next highest is a 3. So this is positive plus 5x cubed. And the next one, if this is very long, after you write each one, cross them out so that you don't get confused. And next one is a square term plus 4x squared. Next one is x term plus 9x, then constant term. So this is our descending order. By the way, this is exactly same polynomial. Just write it in this descending order. And there's a reason we write polynomials in descending order. First, if everyone writes that a polynomial the same way, it's easier to communicate because we do things in the same format, follow the same rules. That's one reason. And there's another reason, actually, mathematical reason. The reason is not actually it's out of the scope of this course, but I'm going to mention it here. The behavior of this polynomial, polynomial like a person, they have their own behaviors. The behavior of this polynomial is dominated by the leading term, which has highest exponent. So this is a dominant term. That's why we write it in the descending order. This is like a VIP. It's most important term among all of these terms. Okay, move on to the next one. This is a long one. The highest exponent is 6. So 5b to the 6th power. And the next one is 4th power. And minus 13b to the 4th power. Next one is the third, minus 16b to the 3rd. Next one is a square plus 10b squared. Next one is single b minus 12b. Next one is constant plus 19. So it's super easy once we understand the basic concepts, right? This is your exercise. Now, I guess this one going to be our last topic, maybe second to the last. We want to simplify polynomials in one variable by combining like terms. So what are the like terms? Like terms are either constant terms, that means they're all numbers, or variable terms that have same variable parts. Let's look at a couple of examples. Next page. It's much easier to understand it if we look at examples. So these are the examples of like terms. So these two are like, they're all numbers. These two are like because they have exactly the same variable part. It's like 3 apples, 2 apples. They're all apples, right? So suppose X represents an apple. That's why we call like terms. They only differ by quantities. Otherwise, they're the same thing. They're like terms. Same thing. Variable part are exactly the same. Variable part are exactly the same. You have one of this xy, you have 6 of this y, they only differ in quantity. And this is some examples that are unlike terms. They have a different variable part. It's like this is an apple, this is a banana. Something like that. Same thing. X squared, x are not the same thing, even though both have x. X squared y, x y squared are not the same thing, even though they both contain same variables, but they have different power on different variables. And this one particularly you need to pay attention to. This is not English, this is the mathematics. And in mathematics, sometimes lowercase and capital case of the same letter represent totally different things. So don't treat them the same. These are two different variables. As a result, they are unlike terms. Okay, now combine like terms. Just like apples can add to apples, you can combine like terms. When you combine like terms, only combine quantity, you don't change variable. Apple plus apple, no matter how many, you still get apple. You don't get bananas when you add apples together, right? Hopefully this makes sense for you. So we get a 13x here. -2 minus 5, or you can say -2, another -5, totally -7. Just copy the variable part. Apple plus apple, you always get apple. Hopefully this makes sense for you. -12 combined with +7, that's -5. So we only check quantity when they combine like terms. Now, certainly these two are exactly opposite. The result is 0. Okay, we just get one more example here. Simplify and write the resulting polynomial in descending order. When they say simplify a polynomial, it's just another way to say combining like terms. So let's do that. Since we need to put it in the descending order, we try to combine the highest degree ones first. So this one and this one both have second degree, +9, +2, that's +11 for x squared. Next one in line is x term, that's +7, -7, cancelled. We don't have any x terms left, right? We only have two constant terms, +5, -8, that's -3. Now we simplify it. Yeah, that's how it is. And this is your last exercise set. There's many in this video, 8 of them. And post your comment or questions in the comment area below the video. See you in the next video.